Hey guys, I'm Mahit and you're watching Ambition Wisdom. Today, we'll be discussing the topic of decision tree analysis, which is an operational research topic. And without further ado, let's hop into the video. So, today, we will be covering today's coverage of topics will be Introduction to Decision Tree Analysis, where we'll be seeing what is a decision tree and what are decision tree analysis algorithm. We'll take a simple example and solve the decision tree, and we'll see the advantages and limitations of the same and end the video with the conclusion. So, hopping to what is a decision tree. A decision tree is a decision support tool that uses a tree-like model of decision and their probable consequences. Possible consequences, which includes change in event outcomes, which also requires resource costs and utility. It is one way to display an algorithm that only consists of conditional control statements like yes or no's, like your if statements and henceforth. So imagine there's a decision tree where you which is made to accept a job offer. So the job offer is offering you a salary of $50,000. Then if yes, there'll be more questions, and if no, you'll decline the offer. So in the end, the decision will be either you'll be accepting the offer or declining the offer. But to like understand which is better, like either accepting offer is better or declining the offer is a better solution, we need to analyze what's happening, and there comes decision tree analysis. So decision tree analysis is a graphical representation of various alternative solutions that are available to solve the problems, and here we are trying to find the better expected value. So what's an expected value? Expected value is an average result procured on a long-term basis. Like it's not like if you take a week into consideration, if a shop is for sale, there'll be days where they'll be experiencing profit, and there'll be days where they'll be experiencing a loss. But we are trying to find the average earning of that week. If you think the average earning of the week, you can say it as the expected value. So this is how we calculate the expected value. We sum all chance, like percentage of chance of occurrence multiplied by resultant value of that occurrence. Let's see a small and a simple example on it. So let's imagine John wants to start a donut shop or a candy shop. He wants to decide which one would be better. So let's see what are all in store for us. So for both donut shop and candy shop, there's a 50% chance of profit and loss. So when it comes to donut shop, the profit will gain is a price of $100, while the loss will incur a $30 loss. Uh, on the other hand, we have candy shop where profit will give you $90 and loss incurred will be $10. So let's summarize the given problem and see what are all the given data we have. We have uh, do, uh, the donut shop with its profit and its losses, and the candy shop with its profit and losses. So now at first glance, when we only see the profit, donut shop seems to be much profitable because it's when we see on upon candy shop, there's a $10 you'll be having a $10 better profit when compared to a candy shop. But when it comes to losses, you lost more. Like you'll be losing $30 instead of candy shop losing just $10. So candy shop is kind of less risk rate, like you can say like that. You'll be having less risk. So upon calculation, the expected value of donut shop is $35 and expected value of candy shop is $40. So upon graphically representing this problem, John, just taking it as a person, has two options: a donut shop and a candy shop, where in terms of donut shop he has 50% profit chances, and upon profit he'll get $100, whilst when there's a 50% chance of loss and he'll incur $30 of loss, and the expected earning will be $35. While on the other hand, the profit will be the profit of candy shop will be $90 and loss incurred will be $10. So the expected earning will be $40. So here we can say candy shop is better than donut shop, but this is just a small example where you can even go in depth and add some more layers to it, and to have a better decision, you can consider more consequences. And if you choose candy shops, you can even go into it and say what ingredients should be used and what ingredients are better. So when it comes to advantages of decision tree analysis, you don't have to do a lot of preparation for pre-processing when compared to other algorithms, because there's no need for requirement for normalizing the data or scaling of data, and even missing values in the data does not affect the process of building a decision tree to any considerable extent. And decision tree model is very intuitive and easy to explain for both technical team and stakeholders. You can because it's graphical and straightforward, it's easy to understand. On the other hand, when it comes to limitations, even small changes leads to big changes in the tree, like the structure of the tree. So usually data should be as accurate as possible, and because it's a iterative calculation process, it's you have to repeat every process every step at a time, which leads it to leads to taking more time to train the model, and hence being very expensive compared to others, because it again is complex and takes a lot of time. Since it depends on every single step for calculation, you can't apply regression or either predicting continuous values. So let's summarize what we learned today. Decision tree is a graphical representation of various alternative solutions that are available to solve the problem. We are trying to find expected value, which is the average result procured on a long-term basis, not every iterative outcome. The expected value is sum of percentage of chance of occurrence and multiplied by resultant value of the occurrence. It's easy to explain to both technical and non-technical people, but on the other hand, even small changes in the data itself might lead to instability and cause large changes to the structure. So with this, I'll be ending the video. If you have any doubts or if you have any corrections to make, please leave it down in the comments, and I'll I'll be ending this video with this. Thank you. Have a nice day.